2,955?
Yeah.
And how many million are we going to do that by?
5.
5 million. All right. Hey folks, welcome out there this great afternoon, or some of you may be looking at us online. Mathline online is the way to go. And YouTube, all sorts of good things. So we're glad you've tuned in. I'm Ernie Roberts. I'm your host for Specialized Segments, and this is test prep time, all right? So enjoy, take some notes, get your math problems out there, get your pencil, paper, calculators if you think you need them, and let's do some math, all right? And let's see what our topic is that we're going on today with test prep. So big, we have corollaries. I bet a lot of you are going like, what's that mean? What's a corollary? I haven't heard of that one. And many of you are saying, I know what they are. Well, let's take a look at it, all right? First of all, what is so big that we have corollaries? It's all about blockbuster. And, you know, I've used blockbuster because it's that big theorem. So that's why I'm saying it's so big it has all these corollaries. I call it one I'm son of blockbuster, but you know it's a theorem. If it's got a few steps, it's a theorem. So let's take a look at this thing because we're going to talk about it today. It says a look at blockbuster's first corollary. Some of you are going like, wait a minute, you've been running your mouth about blockbuster. What is it? Hang on, we'll tell you. Uh-oh, and what's a corollary? So first of all, when we think of the structure of geometry, you got postulates, which don't have to be proven. They're statements we accept without proof. Like we used the parallel postulate to help us get through our friend blockbuster, which was a theorem. By the way, the theorem blockbuster is simply 180 degrees in any triangle, no matter what kind of triangle we're looking at. So what's the corollary? The corollary are facts. They could be called theorems if they didn't have the theorem before it, but basically it's an idea, a concept, a proposition that follows immediately from the proof of a theorem. So in other words, once we have 180 degrees in the triangle, which we've proven by blockbuster, Triangle Sum Theorem, all those great things we want to call it, what follows directly from it? Now the exterior angle theorem didn't really go directly from it. It's a theorem because it picks up 2 or 3 ideas. It's about 4 or 5 steps to prove it. We're talking about in a corollary something that, hey, we've got the idea, we can go to it within 1 or 2 steps, all right? Very, very quickly with little or no proof required after we've established a certain fact. So now that I've babbled and babbled a little bit, let's take a look at what we're talking about, all right? First things first, we do have a corollary. We're going to look at the first, what I like to call the first Triangle Sum Theorem corollary. Big theorem, remember, that big old blockbuster theorem that we've had. And the corollary states the acute angles of a right triangle are complementary. Now, why would I say this is a corollary versus a theorem? Well, first of all, if we understand, and I hope we do, we know that in a right triangle, we have a right angle. Not more than one, just one. So let's box it right here. We'll call it, looks like we're asking for angle C. So we'll go for that. And then we got angle A up here at the top, and we'll put B down here. It really doesn't matter, because what are we trying to say? That they are complementary. Now, my friends, we also have to remember what does complementary mean. All right, complementary means those measures will add up to, yes, 90 degrees. So let's think about it. Keep in mind, what's a right angle's measure? A few little things here, but they're things we already know and things that we just look and we know and we do. So we've got a 90 right in there. So that tells me I have 180 degrees. So let's just write it out a little bit. I've got some room right over here. The measure angle A plus the measure of angle B plus the measure of angle C equals 180. That we know, all right? We also know that C is what? It's equal to 90. So if we put a 90 right in there, and then we subtract that 90 from both sides, look what we've got. We've got measure angle A plus measure B equals to 90. And what do we know about complementary angles? By definition, they add up to 90 degrees. So right there, see how that just followed off from just simply subtracting 90 off of 180 and then saying, oh, that's what complementary means. The angles add up to 90 degrees. So there's a corollary that's really nice to know because we don't have to worry about sticking that 90 in there every time and worry about 180 degrees. We've got 2 angles. And I see my students this a lot. They just go ahead and add that 90 in there, but that's just one more place to possibly make a mistake. You can just start right off the bat here saying A plus B, the measures of A plus measures of B, will add up to 90. and then you can work your problem from there. It's a nice, sweet shortcut, and it's what we call a corollary. Corollary, which basically means that, yes, you got it. It's a spin-off, almost like from the theorem, the blockbuster, okay? We know 180 degrees are in a triangle. Man, if one of them's 9 degrees, the other two add up to 90. Quick mental arithmetic is really what it amounts to. So let's put a little bit of application on that, all right? We're going to put a little spin with that. Let's see a couple of examples, easy ones at that. And we're going to pick this one up to start with. Notice I've already blocked it out as 2 right angles right there. So we've got, goodness, it looks like ADB is a right triangle, as is CBD, all right? And there's your right angle, 90, 90. And I've given you an acute angle in both of them. So the question is, we want to look for the, ooh, I threw a little trick, didn't I? ABC and ADC. And you say, what are we going to do that? How are we going to do that? Well, first of all, we're going to find out what this little part of D is, BDC. Then we can figure out ADC. And if we could get over here to get to, what is that, ABD, that little angle right there, you know, let's make it easier on ourselves. I want to call it angle 1, and we'll call that angle 2, all right? And those will help us get through this problem much quicker, I think. So what have we got going on here? What I see, what you see, what we all see are, oh, we got 90 and 46. Now, some of you are going, well, let's see, if we add 90 and 46, we get 136. We'll subtract that from 180. No. Subtract 90 from 180. Let's use our corollary. Let's use our little complementary corollary, all right? Well, I like that, complementary corollary. Woo! Coin that one. Put that one out there. I don't think I can copyright it. It's probably already been done somewhere. But nonetheless, what plus 46 gives me 90? That's really what's going on. So quick and easy, take 90 and subtract your 46. And I know some of you are punching those calculator buttons. That's okay. But it's going to give us 44 degrees. Quick mental math there. Oops. It is as long as my face stays there. All right, there we go. Now, so we've got a 44 right here. Now remember, we're going to need that in just a minute. So just hang on to that. Let's see what's going on with angle 1. Angle 1 is going to be basically, we're going to take that same story. We're going to take 90 degrees because what? Angle 1 and 38 add up to give us 90 degrees. All right, so how about it? 90 minus the 38. Whew, we're going to see what angle 1 gives us. Looks to me like it's going to be about 52 degrees. I know some of you are saying, let me go to the calculator. That's all right. That's where it is. So we got 52 degrees here. All right, looking. We've got 38 and 52 gives us 90. That's good. 44 and 46, that gives us 90. That's good there also. Didn't have to even worry about that. By the way, you know me, I always have one of these teachable moments, and sometimes it goes bing, bing, a little ADD moment here. Not ADC, but ADD here, all right? We've got alternate interior angles. Did you realize that? And they're both right angles here. So that's telling me something about these 2 line segments here. They're running parallel. Now, let me point out to you, these are not alternate interior angles because I do not know if AB and CD are going parallel, and they actually are not, all right? So, because, no, what we got here? We got alternate interior angles, yeah, but we got 52 and 44. So these that are on the diagonal are not parallel, but these little guys across the top are. Just a little bit of information there, all right? That's pretty cool to notice. But what we're worrying about here, speaking of cool to notice, is what's actually going on from ADC, and also up here, I'm going to see if I can swing some work in here. Let's put a double rim here on that because they're not the same size. They're not the same size. As close as they may look, they're still off a little bit. This one is going to be the 52 plus 90. So let's look at it here. The measure of ABC, and again, my friends, if you can do these mentally, the mental math, boy, it makes it go faster. So we got 52 plus 90, and that's going to give us 142 for this big angle, this big obtuse angle at the top. Yep, it's obtuse. That's a fun word, obtuse. And down here we have another obtuse. Let's look at the measure of angle ADC, and it's going to be worth 44 plus your 90, which gives us 100 and what? I think 134. That sounds good. 134. So there you have some interesting takes. Now, yes, they could have just asked you what are these missing angles here. They could ask you something about the parallel lines. They could have asked you, as I said, the big angles here, where you have to step one little bit further. You got to add the 90 back in. Read your question carefully. See what they're asking for. part of test prep, my friends, is reading the question and reading it carefully, all right? If you don't read the thing carefully, good chance are you think you know what the answer is. You better make sure those answers match up somewhere on those pages, all right? So we've got it going here today. We're looking at some test prep questions and a little bit right now, a little bit about right triangles. Let's take another look here. Quick going here. We're going to solve for x and we're going to solve for y. Now this time it didn't just pop out as x. We got a little 5 attached here to the y, and here we've got a 4 attached to our x, which means multiplication. So if we were to figure out what x and y are, which we're going to do, we could also check very simply by multiplying that by 5 or multiplying by 4 as the subject, as the need is. These are straightforward. Once again, you know me, I like to make things as straightforward as possible. Some of you say, no, you don't. Yeah, I really do. I try to very much. Now, speaking of which, let's go to our first point of order right here. We've got 4x and 40. What do we do? They're not equal to each other. Now, folks, let's not get the word congruent and complementary confused, all right? They are complementary. We could add 4x plus 40 plus 90, but waste of your time. Let's go straight to 4x plus, what did we say, 40 equals to 90. Why? Because those two angles are complementary. Our good old corollary to the Triangle Sum Theorem says acute angles, by the way, they are acute. They definitely have to be acute because they have to add up to equal 90. So one of them has to equal something. Actually, they both have to equal something. So guess what? They're both going to be greater than 0, but they're going to be less than 90. So they are acute. And speaking of which, let's get rid of that 40 while we add it before I lose any of you. And we have 4x equaling to 50. Now divide it out. Some of you may want to go to the calculator on this one because you say, Ernie, 4 doesn't divide into 50 evenly. Well, it goes in there evenly, but you're going to have a little bit left over, all right? And it's going to make a nice decimal. So let's take it real quick on here. How about it? 50 divided by 4 equals, I think it's going to be 12 and a half. It is 12 and a half. For those of you who like fractions, there you go. For those of you who don't, we'll put a decimal down there just for you, all right? Now, on the other side of the picture, we have another storyline going here. We got 5y plus 50. Well, again, yeah, the yellow triangle looks differently than that, but still it's the same. We have a right angle involved in both of those. So they're right triangles. So the rule, you got it. The two acute angles are going to be complementary, so let's let them add up. 5y plus 50 equals to our 90. That's straightforward. Get rid of that 50 right there. And that's what we're going to do. We're going to subtract both sides. Good old friend called subtraction property of equality. And we got 5y equaling to 40. And our y value, my friends, is equal to 8. That's what we're looking for. Now you say, Ernie, are you sure? Well, I hope I am. How about it? 5 times 8 is going to be 40. 40 and 50 does add up to 90. Over here, back a quick check. 4 times 12 and a half gives us 50. 50 plus 40 gives us 90. So both of these ideas check through, but see, it's a little bit easier. You're just equaling 90. You don't have to worry about plus 90 equals 180. Then you're going to be right at the same place, all right? So, again, use your corollary. When it helps you out, go for it, all right? It's a good thing right there. Now, let's take a look at our next corollary, actually. I think that's a good practice on that. We may get another problem shot in here if we have time. Next corollary is that each angle of an equiangular triangle measures 60 degrees. Now you say, well, does that make sense? First of all, equiangular means what? They're all the same, so let's call them x. There's an x, there's an x, one more x, 3 x's. And good old blockbuster, good old Triangle Sum Theorem says if we add all 3 of those x's together, we get 180 degrees. So here we go. X, just going to work it out here real quick, equals 180. You all can go ahead and say, oh, that's 3x. Equals 180, and this comes really quick. That's why we call it a corollary. It doesn't take much effort. X is equal to 60 when you divide the 3 into 180, and most of you probably could have left out that step. It's simply stemming from the fact, oh, see 3 x's, they equal 180, divide, we're done. And let me point out something else to you. Equiangular and equilateral triangles are one and the same. Now, that doesn't work for other polygons because it doesn't always have equiangular. Quadrilaterals are not always equilateral, all right? Think rectangle, okay, with all 90 degrees, those kind of things. But when it comes to a triangle, yep, if these angles are all the same, and that's what we're saying, equiangular means all the angles are congruent, they have the same measure, same degree measure, it has to be 60 degrees in each one of those. And that's a fact that's nice to know, because if you see that situation, you see tick marks. When I say tick marks, you might see those all marked there. You know, equilateral, 60 degrees in each angle. Quick little hint for your ACT, your SAT, and that end of course test that a lot of you take in your geometry classes. And speaking of which, let's do another quick algebra problem. How about it? Let's see what we've got here. So solving for x and y in this good old lovely equiangular triangle. All right? Let's see what we're going to do with it. First of all, let's make it clear. That is a 6x minus 3 in a parenthesis with a degree marking. All right? Sometimes those little degree marks look like a 0 power. They're not an exponent. They're just degrees. But what do we know? Well, what do we know? It's equiangular. Remember I said we could also call it equilateral? What did we just figure out a minute ago? 60 degrees in each of those. So we're going to go right to the source here. Don't try to set them equal to each other. No, you don't need to do that. Just say 6x minus your 3 equals to, got it, 60. Isn't that easy? And on the other side of the coin, let's do the same thing. 5y plus your 5 equals to 60. Life is good. It's even better because these numbers are fairly easy to work with. Let's add 3, move this thing along, put a 63 there and a 6x here. Divide 63 by 6. Oh, it doesn't come out even. Let's go to that calculator for a minute and then they'll see what's going on. Divide by 3. Is that what we said? No, that's not what we said. 63 divided by 6. I crossed this up a little bit there, didn't I? Helps if we divide, doesn't it, folks? Let's try that again. Be careful with your calculator. It's a sweet thing, but you know, sometimes you miss the button. And we're going to divide. That's what we said. So you're going, how do you get 670? And it's not a degree, so there we go. 10.5. That is my value of x that I'm looking for. 10.5, 5/10, or 10.5 if you use the fraction. And we'll check in just a minute, make sure that works. Now, coming along here, let's see what happens if we take 5y plus 5 equals 60. We're going to subtract that 5 this time because that's what we do to move a positive 5. We're going to have to subtract, send to the other side. By the way, be careful when you see something like that. Don't subtract 3 from 60. Remember, we've got to move it by plussing. So over here, we've got to do the minus business. Let's see what's going to happen. I'm seeing 5y. I hope y'all are too. And I see 55 because that's what happens when we subtract 5 from 60. Your y value is 11. How about that? Either one of those makes a good problem for one of those things to understand what equiangular or in terms equilateral. Remember I said you can also have that word. Check it. 5 times 11, 55. Add 5 to that. I'm seeing 60. You see 60. We all see 60. Put in 10.5 times 6. Well, you overshot 60. You got 63, but guess what? You get to subtract the 3, which is good news because that gets you back to 60. So these both check through in a good fashion. Always good to do a quick mental check, or let the old calculator take care of it for you. That'll work also. Very easy stuff, you say. Well, good deal. There's corollary 2. How about it? See how quickly that evolved? Just bam, bam, 1 step or 2 steps, depending on whether you put x plus x plus x to begin with, or you just went straight to 3x, and then it's easy dividing. Now, let's look at another one here. This one is just hopefully going to be some common sense to us. I kind of looked a little dark on that triangle, but we got a right angle down there. That's 90. So it says there can be at most one right or an obtuse angle. Well, if we put a 90 in there, guess what? These two angles have to add up to 90. They have to equal something. So there's no way I can have any more right angles, okay? So at most means a right or less, all right? So in other words, if I had an acute triangle, all 3 of these would be less than 90. Life is good. So that checks it for a right angle. What if we have an obtuse? Well, it's even worse. Let's say this was 91 degrees or 90.5 or 100 or 120. You're still going to have the situation where you can't get any angles that are greater than 90 when all of them have to add up to what? 180 to begin with. So here's the deal. We can call this A and B once again. So if we've got the measure of A, I'm going to use the 90 because once we use the thing to be greater, this thing to be a greater than 90 angle, it works just as well. This is the minimal. Plus what is it, B? Plus that 90 equals to 180. So once again, seeing what's going on. Move that 90 over there. We know those angles are going to be complementary. That much we knew from the last corollaries. So that's pretty straightforward. But it also means unless A was 0 or B was 0, which wouldn't make any sense because that means there's no angle there. All right? So you've got to have, and it's got to be a positive. So it's somewhere between 1 and 90 here, but somewhere between 1 and 90 there, as long as they add up to 90. All right? But they can't be a 0 and they can't be 90s there. So that's what we're saying. Can't have more than one right angle. All right? Now, if I put an obtuse angle, let's say I put 100 in here, that means I've only got 80 degrees left to work with. Well, there's certainly, both those have to add up to be, they're both going to be less than 80. So they're certainly not obtuse. So only one right angle, only one obtuse angle. Won't see any examples on that one, but just a good fact to know. Third corollary on its way to you there, all right? Let's take a look at one more quick corollary. Should make sense. And again, keep in mind, the whole idea is these follow immediately from one another, all right? So let's see, if I'm going to let this angle right here and this angle right here, are they going to be congruent? And then I'm going to bring these two guys at the top. So let's read the corollary. It says, if two angles of one triangle are congruent to two angles of a second triangle. Now, I didn't say they're congruent to each other in here, all right? They could be. But these are just two distinctly different angles, but they match. They match. So the question is, what's going to happen with the third pair? Well, you know, as long as these have these look like they have the same size, okay? But it's still about shape. I could have made this a miniature version, all right? But you know they're going to always do what? No matter what the size or shape of the triangle is, it's going to always add up to what? 180 degrees. So if these two angles have already added up to a certain number in both cases, guess what? If you got to have 180 maximum and exactly on any triangle for the measures, these two have to match. So in other words, we could say here we got A, B, C. How about it? We'll go D, E, and F. But if we're going to say that angle A is congruent to angle D, we'll get it right in a minute. And you got angle B going to be congruent to angle E. What this is simply saying is that this last pair, this third pair, if you will, angle C will have to be, this is the if, here's the then. It has to work, Because why? Blockbuster says 180 degrees in any triangle, no matter what the shape or size is. That's what we're using there. So another fourth corollary. You say, are there more? Not on this one, okay? We got some other corollaries that come from some other theorems in geometry, but not from this one. Let's take a look at one more kind of mix and match it all up problem here, all right? Whew! One number on the figure. 3 letters. Are you ready? Draw that one down at home, folks, and let's go through it, all right? First of all, I threw some parallels in here. That's really nice. There's two triangles here, all right? No, there's 3 triangles. There's one right here, there's one here, and then there's this one. So it's kind of an overlapping situation. It's pulling and mixing them together. And what we need is to figure out how are we going to go with this? Well, let's first of all notice the 40 degrees is rather important down here. I think it's rather important because if you look at this big triangle here that has little old x in it, look at that, the big triangle with x in it. I've got a 40, I've got a 90. Guess what? You got it. What have we got? Not congruent, no. What have we got? Complementary, exactly. There's our good old right triangle corollary working along there. Okay, complementary angles. Well, what does that mean? It means they add up to 90, correct? And we have a 50. 50 degrees. You good? Everybody's going, okay, all right. That's good. Ooh, is it good? All of a sudden now I've got to work to y. Well, 50, that doesn't work. Does it? Are they the same? They might look like it, but I really don't have any way of knowing. Or do I? Let's go to these parallels. I put them in there for a reason. Okay, they're very important. They are very important. Parallel lines usually are telling me there's some congruent angles hanging out. And right here is where the congruent angles are hanging out. Look, how about that working? Woohoo, you got it? Why? Corresponding angles. All right, they're corresponding angles, the same relative position on that transversal. So kick it up here. Big, big, big right triangle. Complementary angles. We have a 40 here. My goodness, we're going to put a 50 right up there also. You say, is all the answers 50? We've got z left. What's my z back here? What's my z right here? Oh, they're parallel, aren't they? Aha! Right angle going right there because corresponding angles. Use a quick linear pair. Got it. 90 degrees, right angle also. So there you go, a little bit of look with corollaries. And if you're on the lookout for these things, parallel lines, the corollaries, what have you, makes it a lot easier and not as hard to compute. Hey, take care, and we will see you again next time.